Okay, what's going on? The plan is next week, Tuesday, we do a chapter 24-26 test. On Thursday, we do a review for the final. And then during finals week, during our class time, we'll take the final. So that means Sunday, Monday, Tuesday. Tuesday would be a good time to take the final. And then that'd be the half that are here. The rest of you will end up taking it late, of course, probably, for whatever reason. Now, how did that happen? Oh, there we go. Now I'm all set. Anybody got an answer to the first one yet? How come? How come I can't even? Come it doesn't fit on my paper? There we go. You like A? Okay, we'll go with A. The time a rectangular waveform spins high. Well, we've never heard of that before in our life. This is the time it takes before it starts going down, so it ain't that. And cycle time, that's a set of words we never use together either, so it has to be A. All right. Problem number 2. Okay, so we have an IC, a 555 timer. Okay, and we remember that the operating frequency of a 555 timer configured as an A-stable multivibrator is 1.44. Well, it doesn't look like 1.44. 1.44 divided by RA plus 2RB times C. 1. All right, so 1.44. Well, I guess we just put it in our calculator, not try to write it with a stupid pen. All right. What? Who? Yeah, the recording will be done for next semester. That'd be good. 1.44 divided by parentheses. Let's see, 2 and 47. 2 and 2 times 47. Bummer. So 2 times 84, 94. 2 times 94 would be 96. Okay, so that'd be 96 double E3. Okay, divided by C1. 0.1 double E minus 6. Boom. I get 150. That looks like the delta answer. Yes, that looks like the delta answer.
Kilohertz or hertz?
What do you think? What did your calculator say?
That kind of wrote hertz.
Well, my calculator said hertz as well, and that's why I marked D. I know that's weird to mark the right answer, and that's unusual. Okay, back to number 3. The time required to come out of saturation. Out of saturation. Well, if I'm coming out, it's probably not rise time. If I'm coming out, it could be fall time, I suppose. Could be delay time, too. All those things make reasonable sense, right? But unfortunately, there's only one answer, and that is... What is it?
A.
Yeah, C, right. Anyway, luckily we'll get a second opinion on the test, and judging from current situations, that's probably going to be required here. All right, number 4, the inverting Schmidt trigger. Upper and lower trip points. All right, so the upper trip point is RF2 divided by RF1 plus RF2 times the plus output voltage. All right, so I know RF1, I know RF2, 1.2 K, 1.2 K divided by 1.2 plus 3.3, that looks like 4.5. 4.5 K. Do I know the output voltage?
Yep.
What is it? I don't know the output voltage. I know the power supply voltage, but the output voltage is going to be 0.7 less than that, plus or minus a little bit, right? So the output voltage is going to be 14.3 or thereabouts. And the lower trip point is going to be the same thing times minus the output voltage. Same numbers again, except there'll be a minus sign there. So I put that in my calculator. 1.2 divided by 4.5 times 14.3, and I get 3.81 volts. Okay, so I come back up here and I say, well, it's obviously not that guy, it's obviously not this guy because they both have to be the same, and it's obviously not that guy because they didn't do the minus 0.7 for the dial drop across an operational amplifier. So my 0.7 is not a hard and fast in stone drop, therefore the only guy it can be is B.
Can you scroll down just a little bit? Thank you.
I guess I'm out of problems. Yeah. Well, I could go. I suppose I could go get some more problems, right? So we're going to. Okay. A switching circuit that produces an output that is a pulse. I read that one wrong, didn't I?
Yes, you did.
I'll try it again. A switching circuit that produces an output that's in phase with the input is called what? Delta is correct. A binary junction transistor acts as a closed circuit. Closed means the switch is closed. That means current's flowing. When it is driven into, obviously we don't use that word. We don't use this word. So the only two things it could be are those two words there when we talk about transistors, right? So we want saturation Charlie. I agree. A valid trigger signal for a one-shot is, and this is on page 869 in case anybody was wondering, 869. And what do we have for an answer? That is wrong. A is the correct answer. Assuming negligible rise and fall times, what is the duty cycle? Okay, so the duty cycle is the time on high divided by total time. Times 100%. All right, well, let's see what we got. We have 12 on high divided by 12 plus 60 times 100%. That's 5, right? 5 times that is that, so this is 1/7. Well, obviously not that guy, not that guy, that guy, that guy. So, but if I put it in my calculator, I bet you it's the other guy that's left over. What do you think? No, it's not 1/7. It's 1/6. All right, can't add 1/6. Anyway, it's that guy right there, B. Now, number 9, a 555 timer configured as a one-shot and pulse width. So pulse width is 1.1 RC. So 1.1 1 meg times 47 microfarads. All right, well, the answer is going to be in seconds, and it's going to be sometime greater than 47, right? So it can't be that guy, it can't be this guy, it can't be that guy, so it has to be that guy. I assume that's 51.7 sitting there, is it not? Yeah, C. Scroll down. 51.7 seconds. Well, that's a pretty long time to have a one-shot on. I mean, my nuclear weapon's going to blow up in a thousandth of a second or so. What good is a one-shot that puts out a pulse that long? No, we got to stop the video. Okay, so we made it all the way down to 9.
C.
All right, so anybody not want C for 10?
I said D.
You said D?
Well, I said C next round, right? My real one is D.
Oh, the real answer is C. A fail-safe circuit that's designed to protect voltage-sensitive loads from excessive inputs of voltage.
How's a crowbar gonna do that? It's not a crowbar. It's a crowbar circuit.
It's a crowbar circuit. It's easy.
Circular.
I got my crowbar. It's a yay long, right? And
Just
I
remember who's
know
right.
the voltage is going to start getting too high. I just throw it down. I got a 12,000 volt circuit, and it goes right to ground. Does that work? That work for you?
I'm gonna go to the job.
I did. Okay. So now do we understand how the crowbar circuit works? That was so obvious I didn't bother to put down where in the book it was, but it's in chapter 25 is where the crowbar circuits are.
Well, I was right.
Yeah, there we go. The process of varying the duty cycle of a rectangular waveform without affecting the total cycle time is called. Charlie is correct. Pulse width modulation. Pulse width modulation. In fact, that is exactly what's happening on the PowerFlex 40s, producing the variable speed signal going to your motor. So that's 2 C's in a row. Number 12. The load regulation is given by Delta's wrong. Bravo's wrong. A's wrong. So the correct answer is C. Okay, excellent. Finally got that one right. Yeah. So we're regulating the load, voltage out divided by change in voltage out, change in current out. Okay. Well, at least we covered all the answers on that one before we came back to agree on the right answer. I don't know, did we ever agree on the right answer, or was just the instructor agreeing on the right answer? I forget.
Oh, we agree with him.
Oh, everybody agreed with me?
I don't let everybody.
Yeah. That Steve guy, though, he didn't agree, right? Oh, one of the Steves agreed.
The only one did.
Only one Steve agreed. Okay, number 13. Now we've had 4 C's in a row, right? So we'll cross off C as the right answer in this problem because we know we can't have 5 in a row. The ideal voltage regulation maintains a constant DC output regardless of changes in. Regardless in. So somebody says D's wrong. Okay, D's wrong.
Yeah, that's what I said.
Regardless of, now both of those say input voltage, and one says load current. Now, does the phrase load voltage demand make sense?
No.
In an English way?
That's why it's A.
That's right. So it can't be, this makes no sense at all, low voltage demand. So that means the answer has to be A. Yeah.
Translated makes sense.
All right, so it's back to C on the next one.
No, it's gonna be D.
B. Your mom's gonna be E.
Okay, Charlie for 14, that's correct. IC voltage regulators are not very expensive. They are used all the time, but they are 3-terminal devices. So the only thing that makes any sense would be C. All right, number A. Somebody wants A? No, A is wrong. Number 15. The MC 7912 is, Delta, that's correct. Right there. See that 12 right there?
Right.
That 12 and this 12 over here. Notice they're both 12. They both have a 1 in front of the 2. Yeah.
Even with the curve, that makes it about 50%.
Yeah. All right. For an SCR to conduct.
They pay $5.
Okay, so an SCR only conducts in the first quadrant. Okay, so it's only going to conduct in the first quadrant, right there, 1. Okay, so it's going to have a positive gate. Positive gate, positive gate. Both of those have to be wrong. All right, now, Negative anode. Now what does anode mean? Anode means add, which means positive, right? So anodes are things that are positive. Cathodes are things that are negative, positive gate, delta. All right. Number 17. An SCR can be made to fire with no gate voltage when the gate is shorted to the cathode. Probably not. It is used as a crowbar. Well, we already covered that, so that's obviously wrong. The anode voltage is more negative than the cathode. No, that'd be reverse biased. So D, if I change the voltage real quick, I can turn on the SCR. That's one of the things that turns it on. So cosmic rays will turn it on. Changing voltage, changing time, being too quick will turn it on. Voltage at the gate will turn it on. Those are the four things that turn it on. Those other things that are there won't turn it on. I hope you're all keeping track so you know who has them all right so far. And I apologize ever so slightly for wasting the entire last the last hour of before class, solving these problems before coming, because it's much more fun when I don't know the answers, right? It's much more hilarious that way. But that's just the way it is. When an SUS, let's see, what is that? That's a, whatever it is operating in the reverse bias region, it has the same characteristics as a, well, let's see, we'll cross out Bravo, that's wrong. And D's wrong. And C is wrong, so it only leaves A. Right. So it looks like a reverse bias diode. Why are diodes included in the feedback path of some SMIT triggers? Well, clearly it doesn't have anything to do with gain, right? And it has nothing to do with frequency response. And it has nothing to do with the shape of the waveform, although it may have something to do with the shape of the waveform. It's to allow unequal values of the upper and lower trip point, delta. But that would sort of, to be D, that would sort of imply the waveform got changed, right? Yeah, so
Definitely never say.
So that could be
Very generally.
that could be confusing. A circuit with one stable state is called a monostable, also known as D. All right, 21. All right, so the upper trip point minus R in divided by RF times minus V out. Now in this particular example, unlike the one we had earlier, we're given V out, right? So that'd be minus 12K divided by 15K times 5 volts, which is 4 volts. And there's a minus sign there, 4 volts. So it'd be 4 volts, and if I did it again for the lower trip point, I would get minus 4 volts. So do we have plus and minus 4 volts? Yes, we do. Upper trip point, lower trip point, B. (21) A shunt regulator must be protected from Let's see. A shorted load. Well, if the load is shorted, then the shunt guy doesn't really care, so that's not it.
I agree, Charlie.
An output over current condition. No, because it's a shunt thing.
D, bravo. Why would I?
Okay, show of hands, how many would like D, bravo, to be the correct answer? Okay. How many would like D, delta, to be the correct answer? Oh, I'm sorry. Well, the correct answer is bravo. What exactly is an output over voltage condition? Explain that to me. Let's see. I got this input right, and lightning's gonna strike, and the input's gonna go up, and it's gonna cause the output to change. But what is exactly an over voltage condition in the output?
Well, that's highly classified.
Yeah, So that might be an Air Force problem, but that's definitely not a Navy or an Army problem. That's for sure. Yeah. So that just, how,
Say something, man.
it's just, how can we weasel word these things, So some Englishmen, did I ever tell you that it was back in the mid-'80s? The Navy has tests for advancement and rate, and you have to get so many right in order to get advanced. And some PhD education female decided she would take all the Navy placement exams. So over a 2-week period, she took everybody's exam, and she passed high enough to be promoted in all the ranks, not knowing any of the material at all, following simple educational rules of the longest answer is always right. Things. Just totally amazing. So those things can happen to us. Oh, the schedule is up in grabs for the fall. Someone decided that adjunct instructors, it used to be that they could teach 15 credits a year, and so you could teach 15 credits in the fall and then not at all in the spring. You could do that. Well, now we've changed those rules, and we say, well, they can teach 18 credits a year, but no more than 9 in any semester. Now, Paul is currently scheduled for 10.2 hours. So now we're trying to figure out what the exact rules are and what we can get away with. And what I think the right answer is going to be that we go and make 4 sections of the microprocessor lab. And when we do that, and then we limit each of them to 9 people, because now the class isn't full and doesn't count against that 9-credit limit. I think that's what we end up doing, and but it's causing some hate and discontent.
So if we're already signed up for classes, is that going to affect what class we're going to be in next year then?
No,
Okay.
no. What it's going to do is going to require me to add some sections to the schedule, so that I don't run afoul of the credit limit. And of course, how many credits is a 1-credit lab?
1 credit.
How many? Right now, yeah, okay, right. You guys, you're all sitting down there, right? All right. So how many credits is a 1-credit lab?
Like a trick question or what?
No, it's just for people that aren't dumbasses.
Yeah, right. How many would like the answer to be 1? Okay, so that's 2 people. How about 1.1? Anybody want 1.1?
Why not?
Okay, there's 1 for 1.1. Connor wants 1.1. Okay, how about 1.2? Anybody want 1.2?
It's gonna be 3.
Yeah. Well, the right answer is 1.4. So there's 1.4 credits for a 1-credit lab. So if my adjunct is teaching 2 4-credit classes, that's 8. And a 1-credit lab, that's 1.4. So now he's at 9.4 and he's over the limit already. Yeah. Yeah, I know. It's and just another cross the program sure has to carry. The good news is UNO has an introduction to quantum mechanics class on Tuesday, Thursday at 4 o'clock in the afternoon that I'm going to be taking in the fall. So that means I can leave here around 3 o'clock on Tuesday, Thursday and not worry about it. Anyway, back to number 23. The Zener diode, let's see, Zener diodes with extremely high surge handling capabilities are known as, all right, obviously not variacs because that's those are things that vary the capacitance, right? And they obviously aren't opto interrupters because that makes no sense either. So are they tunnel diodes or are they transient suppressors? Right. So show of hands for B, as in boy. Nobody wants B.
I want B.
All right. So we 2 B's. Okay. Show of hands for delta. All right, delta has it. Delta is the right answer. That's correct. Transient suppressors, high surge handling capabilities. All right, diodes that operate at ultra high frequencies. Yeah, microwave frequencies. Well, again, not those guys, not those guys. Not those guys. So that only leaves Bravo. So your Zener diodes you're putting in applications where you're using DC stuff. I mean, you're not using Zener diodes in anything high frequency. Okay. Another English problem.
D.
Delta?
Yep.
All right, so we can cross the, who was that? That's Chase?
Yeah.
Chance? Yeah, we'll throw that one away.
Who the fuck is Chase?
All right, anybody else want an answer thrown out?
C. Yeah.
Throw out Charlie?
It's A. It's the longest answer. It's A.
No, we're throwing answers out. We're not picking the right one yet.
Oh, sorry. I mean B. It's B.
Let it go. Wait. Oh my god. Dude, you're sleeping.
Okay, correct answer is B. The voltage regulator that is designed so that the current path between the regulator input and the load output is not continuous. Right. So that would be a switching regulator. That's absolutely right. And so it's B. That's very good. Now, only 2 more to go. And we already did this. We already did the math on this one already. So pulse width is 1.1 RC. And so it looks like we're going to, whatever it is, it's going to be in milliseconds, right? But it can't, so it can't be that one, can't be this one. So it's either B or C. It would be C if I wasn't multiplying by 1.1, but I am, so it must be Bravo. '27. The circuit that uses series transistors to regulate the voltage load is known as. All right, have we ever said Darlington bypass transistor regulation?
No.
No, we never use those words in a complete sentence ever. So we can throw that one out. It's F?
Delta.
Fire.
It's delta.
I think it's A.
Alright. Series feedback uses a series transistor to regulate the thing. Okay, well, if we're using a series transistor, we can't be using a diode, right? So it can't be called that. So that leaves us A and delta. And A is the longest answer, so that must be right. So A. Pass transistor regulation.
Yeah.